In this video, we tell you what augmented reality means, as well as its technology, history, and application in our world. Before we start, please like and subscribe to this channel, and then sit back and relax. What is augmented reality? AR allows you to overlay virtual objects in real-world environments in real time. Augmented reality is the technology and methods that allow real-world objects and environments to be overlaid with 3D virtual objects using an augmented reality device and allow the virtual to interact with real-world objects to create the intended meanings. Unlike virtual reality, which attempts to recreate and replace an entire real-life environment with a virtual one, augmented reality is all about enriching a picture of the real world with computer-generated imagery and digital information. It seeks to change the perception by adding video, infographics, images, sound, and other details. Within a device that creates AR content, virtual 3D images are superimposed on real-world objects based on their geometric relationship. The device must be able to calculate the position and orientation of objects for others. The combined image is projected onto mobile screens, AR, glasses, etc. On the other hand, some devices are used by the user to allow the user to view the AR content. Unlike virtual reality headsets that fully immerse users in simulated worlds, AR headsets do not. The glasses allow adding and overlaying a virtual object onto a real-world object. For example, placing AR markers on machines to mark repair areas. A user wearing AR glasses can see the real object or the environment around them, but is enriched with the virtual image. Although the first application was in the military and television since the term was coined in 1990, AR is now applied in gaming, education and training, and other fields. Types of AR. Augmented reality is of 4 types: marker-based AR, markerless AR, projection-based AR, and overlay-based AR. Let's see them one by one in detail. Marker-based AR. A marker, which is a special visual object like a special sign or whatever, and a camera are used to start the 3D digital animations. The system will calculate the orientation and market position to position the content effectively. AR, without markers, used in navigation, business, and event applications, for example. The technology uses location-based information to determine what content the user gets or finds in a given area. You can use GPS, compasses, gyroscopes, and accelerometers, just like you can use mobile phones. Project-based AR. This type uses synthetic light projected onto physical surfaces to detect user interaction with the surfaces. It is used in holograms like in Star Wars and other science fiction movies. Overlay-based AR. In this case, the original item is replaced with an increase, in whole or in part. The following example allows users to place a virtual piece of furniture on top of a scaled room image in the IKEA catalog app. Any history of AR. Let's check out a brief history of AR. In 1968, Ivan Sutherland and Bob Sproul created the world's first head-mounted display using primitive computer graphics. In 1975, VideoPlace, an AR laboratory, is created by Myron Kruger. The mission was to have human movement interactions with digital material. This technology was later used in projectors, cameras, and screen silhouettes. In 1980, iTap, the first laptop to win in front of the eye, was developed by Steve Mann. iTap recorded images and superimposed others on top of them. It could be played with head movements. In 1987, Douglas George and Robert Morris developed a prototype heads-up display, HUD. He showed astronomical data about the real sky. In 1990, the term augmented reality was coined by Thomas Caudell and David Mizzle, researchers at the Boeing Company. In 1992, virtual props, an AR system, was developed by Louise Rosenberg of the U.S. Air Force. In 1999, Frank Delgado and Mike Abernathy and their team of scientists developed new navigation softwares that could generate track and street data from helicopter video. In 2000, AR Toolkit, an open-source SDK, was developed by a Japanese scientist, Hirokazu Kato. He later adjusted to work with Adobe. In 2004, an outdoor hull-mounted AR system was introduced by Trimble Navigation. In 2008, AR Travel Guide for Android mobile devices was made by Wikitude. And in 2013 to date, Google Glass with Bluetooth Internet connection, Windows HoloLens, augmented reality glasses with sensors to display holograms in HD, Niantic's Pokémon Go mobile game. How does AR work? The technology behind it. First is the generation of images of real-world environments. Secondly, technology is used that allows 3D images to be superimposed on the images of real-world objects. The third is the use of technology to allow users to interact with the simulated environments. Screens, glasses, handheld gadgets, mobile phones, and head-mounted displays can all display augmented reality. As such, we have mobile-based AR, head-mounted gear AR, smart glasses AR, and web-based AR. Headphones are more immersive than mobile-based and other types. Smart glasses are wearable AR, devices that provide first-person views, while web-based ones don't require you to download any app. AR uses SLAM technology, simultaneous localization and mapping, and depth tracking technology to calculate the distance to the object using data from sensors, in addition to other technologies. Augmented reality technology. AR technology enables real-time magnification, and magnification takes place within the context of the environment. Animations, images, videos, and 3D models can be used, and users can view objects in natural and synthetic light. Visual-based SLAM. Simultaneous location and mapping, SLAM, technology is a set of algorithms that solve simultaneous location and mapping problems. SLAM uses feature points to help users understand the physical world. The technology allows applications to understand 3D objects and scenes, allows monitoring of the physical world instantly. It also allows the overlay of digital simulations. SLAM uses a mobile robot-like mobile device technology to detect the surrounding environment and then create a virtual map and plot your position, direction, and route on that map. Apart from AR, it is used in drones, aerial vehicles, unmanned vehicles, and cleaning robots. For example, it uses artificial intelligence and machine learning to understand locations. Feature detection and the combination are done by cameras and sensors that collect feature points from various viewpoints. The triangulation technique then infers the three-dimensional location of the object. In AR, SLAM helps to place and combine the virtual object into a real object. Reconnaissance-based AR. The camera is used to detect markers, making it possible for an overlap to occur if one is found. The system recognizes the marker, determines its position and orientation, and then substitutes a 3D representation of the real-world marker. The position and orientation of the others are then calculated. The entire item rotates when the marker does. Location-based approach. Simulations or visualizations are generated from data collected by GPS, digital compasses, accelerometers, and speed meters. It is very common on smartphones. Depth tracking technology. Depth map tracking cameras like Microsoft Kinect generate a real-time depth map using different technologies to calculate the real-time distance of objects in the tracking area from the camera. Technologies isolate an object from the overall depth map and analyze it. Natural feature tracking technology can be used to track rigid objects in a maintenance or assembly job. A multi-stage tracking algorithm is used to estimate the movement of an object with greater precision. Marker tracking is used, alternatively, in conjunction with calibration techniques. The overlay of animations and 3D virtual objects on top of real-world objects is based on their geometric relationship. Extended face tracking cameras are now available on smartphones like the iPhone XR, which have true depth cameras to enable better AR experiences. Augmented reality applications. In medicine health, AR can help train healthcare workers remotely, help monitor health situations, and diagnose patients. In gaming, AR enables better gaming experiences as playing fields are moving from virtual spheres to include real-life experiences where players can perform real-life activities to play. In retail and advertising, AR can enhance customer experiences by presenting them with 3D models of products and helping them make better decisions by providing virtual product tours. Just like in real estate, it can be used to drive customers into virtual stores and rooms. Customers can overlay 3D elements on their spaces, just like when shopping for furniture, to select the elements that best fit their spaces in terms of size, shape, color, and type. In advertising, ads can be embedded in AR content to help companies popularize their content with viewers. In tourism, AR, in addition to placing advertisements in AR, content can be used for navigation, providing data on destinations, directions, and tourism. In the military, AR helps in advanced navigation and helps mark objects in real time. In education, AR, interactive models are used for training and learning. In manufacturing and maintenance, professionals can remotely directly repair technicians to perform repairs and maintenance work while on the ground using augmented reality applications without the professionals traveling to the location. This can be useful in places where it is difficult to travel to the location. If you enjoyed this video, don't forget to hit like, the subscription button, and the notification bell to get notified when new videos are uploaded from this channel. Please share your thoughts about augmented reality, its technology, history, and application in our world in the comment section below. Thank you.